All right, let's get going. My name is Ryan Boyd. I'm typically a developer advocate at Google on Google Apps. But today here I'm playing a little bit different role in talking about OAuth and OpenID and how these work in web applications. I apologize for this poll here, so I may actually cross over and talk with you guys over there a little bit too. And I apologize to the cameraman if I do that too much. But so there is my Google Plus profile as well as my Twitter handle. If you have any questions throughout this talk, please save them for the end. We'll have a Q&A period. But you can also ask your follow-up questions there on Google Plus, preferably. So let's get started. Here's what we're going to talk about today. Basically, we're talking about the new versions of OAuth, called OAuth 2.0, and the new version of OpenID, called OpenID Connect. We're also going to be talking a little bit about the user experience with these technologies and how you use the Google Identity Toolkit to enable seamless sign-on to your website while relying on third-party account holders such as Google. And lastly, like I mentioned, we'll have a Q&A section. I'll also give you some links that you can use in order to research some of this stuff a little bit further yourself. So concepts and terminology are key to understanding these topics. So a lot of people confuse these, even people internally to Google. So I want to cover a couple concepts up front, and then we'll be introducing some new concepts throughout the talk. The first concept or term is authentication. Authentication is about verifying the identity of a user, knowing the user is who they say they are. This is typically done on websites by asking the user to insert their email address and password, and you as a web application developer verify that that password matches the user account. This works most of the time, but is rather difficult for users, and we're going to talk about how to make it easier with OpenID Connect. And then there's authorization. Authorization is about making sure that a user has access to their data and only their data, or at least only the data that they're allowed to access. So it's kind of protecting your data behind a safe. And on the web, think about it, when you log into Gmail, you have access to your email and only your email. And that's really important to you when you log into your mail. You don't want other people to be reading it. And then we're going to talk about delegation. This is particularly related to OAuth 2.0. Delegation is about allowing someone else to use one of your resources. So if you're a valet, or if you're going up to a hotel and you stop at the valet parking and you give the valet attendant your key, you're essentially delegating the valet attendant access to drive your car. And in a fancy world, with a fancy car, you might actually have a special valet key. And that valet key will allow the valet attendant to drive your car, but maybe not open your trunk, maybe not open your glove box, or maybe not go beyond 20, 25 kilometers an hour, something like that. So the valet attendant there is getting delegated access, but a limited level of access. And OAuth 2.0 does exactly that. So authentication and authorization on the web. We're going to start off with some polls here. Do you use the same username and password on multiple websites? All right, yes. Most people are admitting it. There's still a few shy ones here, but everyone does that. Everyone uses the same username and password on multiple sites. I even do it, and I work with computer security stuff all the time. Now, I have different levels of passwords and all, but it's very difficult to remember, and it's also quite insecure. How many keystrokes do you think you type every time you sign up for a new account on a new website? Guesses? Shout them out. 100? I was thinking somewhere about 50. Maybe some of you have longer names or longer email addresses or better passwords. But every time that I sign up for a new account, I'm typing about 50 keystrokes. I'm typing my name, my email address, my password, typing my password a second time. We don't want to type that much. We want to make this easier. And we're going to be talking about how we can do that. And then how many of you have shared a password so another app could access your data? So for instance, a desktop app, you've given a desktop app your Twitter password, or you've given a web app your Facebook password. And hopefully you've never done this with a Google account. But how many of you have shared a password for another app to access your data? All right, quite a few. Less shy than the Moscow crowd, I think. So, you guys all give your passwords to your to these websites in order for them to access your data on a third-party data provider. This is bad. We want to figure out how to solve it. All right. So we want to minimize the number of accounts and passwords. We want to discourage reuse of passwords, and we want to optimize the sign-up flow to log users into your applications faster. And that's all OpenID Connect. OpenID Connect is a protocol for federated identity. We'll get in what that means here, but basically allowing you to, as a user, to log into websites using your Google account, AOL account, Hotmail account, etc. All right, but we also want to enable you to eliminate revealing that password to those third-party apps. We want you, when you want to give access to your Google account, not to give over your Google password, but instead to use a protocol. We also want you to restrict the level of data available to third-party apps. So when you log into a website, if you give them your full Google username and password, then they have access to your entire Google account. Whereas maybe you want them just to have access to your calendar or to your docs or to your contacts, but not your whole account. And we do all this with OAuth 2.0. So let's get into it. First of all, though, what data is behind the walls of OAuth 2.0? What data does Google have protected by OAuth 2.0? We have more than 35 APIs just at Google that are using this protocol for authorization. 35 APIs that allow you as an application developer to connect the user with their data and enhance your applications. These are some of the APIs. We're going to be talking about calendar in some of the examples here, but 35 APIs everywhere from business type data like calendar and contacts to things like YouTube videos and Picasa pictures. You can all connect your users with their data on these services. And although Google just has 35 APIs, and I say just, has 35 APIs that use OAuth, there are hundreds of other API providers, hundreds of other APIs around the web that use OAuth as a protocol. OAuth 2.0 is brand new. The spec hasn't even been finalized yet. We're on draft 22. It should be finalized here shortly. But many API providers are already supporting it. And those hundreds of others that are still supporting OAuth 1 will soon move to the OAuth 2 protocol. So let's give you a quick demo of what it looks like from a user experience to use OAuth 2. And I'm actually going to use a Google Plus sample here. It's not the most visually appealing sample, but it's good. Here we go. And if I visit the application here, I'm asked to log in to the Google Plus sample, and I hit login. The application asks for permission for some of my data. This is actually more similar to OpenID Connect, but since OpenID Connect is built on OAuth 2, showing this example. But I'm going to hit allow access. And I'll zoom in here a little bit for those of you in the back. And after I hit allow access, it's redirecting back to the app and giving the app a token. The application then is reading my Google Plus stream, getting my photo, and things like that. So fairly simple user experience for users. But what's new here? So like I said, Google has supported OAuth 1. Many other API providers supported OAuth 1. But there's a big movement here to OAuth 2 to make it better for you as developers. OAuth 2 offers defined flows for different environments. So think about mobile or desktop use cases. Those were actually handled by developers using OAuth 1, but in sort of hacky ways. OAuth 2 puts that in the specification. It basically says, here's how you handle it for these different environments, and has a number of different flows defined for that. We're going to go through a couple of the flows that Google supports, as well as talk about a couple of the others that we do not yet support. But I imagine there will be more and more added as specifications using the extension capabilities provided by OAuth 2. OAuth 2 also offers an improved user experience. Now, it's not the protocol that actually offers the improved user experience. Google has actually made a better user experience, improved the user interfaces for our OAuth 2 approval screens as a way to make it just easier for users to grant access to sites. And for those users that really want to drill down into exactly the data that they're granting access, we allow them to do that as well. The biggest thing with OAuth 2 is an improved developer experience. It basically makes your lives easier. And it makes your lives easier by giving you short-lived, refreshable tokens, and most importantly, eliminating cryptography. So how many of you have used OAuth 1? Okay, handful. OAuth 1 uses cryptographic signatures. Every request that you send with OAuth 1 has to be signed using a key and secret value that's been given to you. And this signature has a timestamp associated with it, has a nonce associated with it, and has other bits of cryptographic goodness associated with it. And I call it goodness because I've grown to kind of love it over the years, but I also hate it. And I hate it because it's confusing for most developers. It's also confusing for our team to support developers and help them debug the issues that they're having. So OAuth 2.0 eliminates this complex cryptography because it relies upon SSL or HTTPS. So SSL and HTTPS are essential for web APIs nowadays, but back when OAuth 1 first came about, a lot of APIs did not have support for SSL. And that is why the cryptographic signatures were there. It was to protect your request, to make sure that if an evil person captured your request, they couldn't just grab a token and reuse it. But now with the protections of SSL and HTTPS, we're able to offer that and make it an improved developer experience for you. So there's 3 types of tokens and codes that we'll talk about through this presentation. There's an access token. This is essentially your end goal. You want an access token because an access token is what you can use to pass to an API to get access to a user's data. But before you get an access token, you might need to get an authorization code. An authorization code is used in the server-to-server flow, which we'll go into details later about. And it's used in that flow in order to represent a grant. So the user grants access to their data, and then you get an authorization code. And server side, you can exchange that authorization code for an access token. And then the last thing we'll talk about in terms of tokens and codes is this refresh token. The access that's granted to you is granted to you for a limited period of time. In Google's case, usually 3,920 seconds, which is about 1 hour. And after that token expires, you need to refresh it. And again, we'll see how that works. The example application that I'm going to use here today is called SaaSy Payroll. SaaSy Payroll is essentially a fake application that I made up, but it's a good for demonstration purposes here. SaaSy Payroll has a place that you can log in as an employee of a company and see your paycheck. You can see your current paycheck, and then you can see your upcoming dates that you're going to get paid. But you don't want to have to log into your payroll site every single time you want to check when you're getting paid. You want that data to be on your Google Calendar. So SaaSy Payroll, answering the concerns of all their users, has added this Add Pay Dates to your Google Calendar button. And when you click on that, it performs the OAuth flow, an OAuth 2 flow, allowing the users to see their pay dates on their Google Calendar. Basically centralizing the user's data in one place, making your application more and more valuable for the users. I feel really bad that I can't see a few of the people up front here, but I'm sure I'll annoy the cameraman if I walk in front of the poll. So, all right. There's different roles, though. We're going to be talking about several different roles as we're talking about OAuth, and this is, again, more terminology that's important to understand if you're reading our documentation, if you're writing code or reading the spec. So first of all, the client. This is a web application. It needs access to protected resources. In the case that we're talking about here today, SaaSy Payroll is the client, and we just went over what it does. So it needs access to a user's Google Calendar. And then we have the resource server. The resource server is what holds that protected resource, holds the user's Google Calendar, and in this case, our Calendar API servers are the ones doing that. Then the protected resources, that's the user's individual Google Calendar, and the authorization server. The authorization server is essentially the OAuth server that provides access tokens for you as developers to use to access this Google Calendar. Google essentially has one centralized authorization server, and this authorization server protects all of our different APIs. Smaller API providers may just have the authorization server at the same endpoint as their API, and there will be no essential difference to you guys. But the authorization server is what issues these OAuth access tokens. And then there's the important resource owner. This is the user. This is the person who has the ability to delegate access to their data. For you as a developer to get started with OAuth 2, we do require you to register. We built this spiffy new APIs console that allows you to register for access for many of our different APIs and register for access for OAuth. And your key goal here is to get this client ID and client secret. The client ID is used in every single OAuth flow. The client secret is used in some of them. But you should definitely get both of these values when you go to the APIs console. So like I said, we're going to go through a couple of these different flows that Google uses. We're going to go through two primarily. There's a user agent flow, and then we're going to go through a server-to-server flow in detail. And then we're going to dive into OpenID Connect after that. So the user agent flow. It's for apps residing on a client device. So if you have a mobile phone or a desktop or a JavaScript-based application, the client secret is not really secure because you need to send it to the users in order for them to run your application. So in this case, you can use the implicit flow, which doesn't require using this client secret. It's also only for temporary access to users' data. So you get this one-time temporary access. The user has to stay logged into their Google account in order for you to get continued access. So here's how it works. You first redirect the user over to Google. You basically form up a URL in your application. You open up the user's web browser if it's not already open in some scenarios, and you redirect the user over to Google. You include that client ID. That's the value that's given to you by the APIs console. You also include a redirect URI. This is the website that your application is running on. It's the URL for your website. And you include a scope. A scope is basically the level of data access that your application needs. So like I mentioned earlier in the valet key example, you don't want to give access to an application to your entire Google account. And you as a developer don't want the risk of having access to an entire user's account or many users' accounts. You want to get access to just specific amounts of data. So we have various scopes that you can use, and one scope means Google Calendar in this case, and that's what SaaSy Payroll needs access to. But if your application needs access to multiple scopes, it needs access to YouTube and Calendar and Docs and spreadsheets, it can actually specify multiple scopes delineated by a space. So these scopes look like URLs, but you can specify many of them at once when you redirect the user over to this place. And then there's the response type. You're indicating that the response type you're looking for is a token. Sorry, I'm blocking the view of some people in the front here, but the response type is a token, indicating that basically you want an access token right away. You want an access token back from OAuth. You don't want this authorization code or anything like that. And this was what indicates that you're using the implicit flow for client-side applications. All right. So after that user goes to that URL and sees that screen here, they click Allow Access, and they end up back at your application. And they end up at this URL. This is the redirect URI. And in this case, it's sasyapp.com/payroll/back. And there's a hash fragment there at the end. In the hash fragment is the access token. Like I said earlier, this is your end goal. You really want an access token because you want to be able to access the user's data. The access token is there, but how do you parse it out? You're used to parsing things out of query parameters, but probably not parsing things out of hash fragments as much. So here's a little snippet of JavaScript. We will publish the slides for you guys to copy and paste that. Don't bother trying to write it down now. That would be painful. But basically, you're just parsing out the values that are in the hash fragment and getting that access token. And then in JavaScript or in ActionScript or in another client-side environment, you can then access the APIs. And you access the APIs in one of two ways. You can access the APIs using a query parameter, and passing the access token as a query parameter. That's the first one I'm showing here. And what that means is you're just appending it onto the URL of the request. Now this is very helpful for JSON-P requests. It's very helpful for debugging, but can actually be less secure than including it as a header. And that's the other option. You can use an authorization header and pass the OAuth token as an authorization header. The parameter here changed a little bit between versions of the OAuth 2 spec, but the latest one is bearer. And as I've tested it with most of our APIs, that works. We also use OAuth 2 instead of bearer in some places, but this will all get standardized shortly. So you can pass the authorization token in as a header. And what that means is that it's less likely for browsers to log it in their caches. It's less likely for proxy servers to log it. It's less likely to be included in your history and all of that. So if you have a chance to decide which way to do it, I would use the header if at all possible. All right, but what happens when this token expires? Like I said, and some of you might have seen this, every token expires, at Google at least. We expire them in about 3,920 seconds, or about 1 hour. If the token expires on you while using this implicit flow, you can just start the same flow over again. You redirect the user over to Google, and they will not see the allow or deny button. They'll actually be immediately redirected back to your application, and you'll get a new access token. And you can do this inside of an iframe or something like that. There's actually some discussion around like a post-message based flow for people in modern browsers and doing this sort of thing. But basically, you'll get another access token in the same way, but the user has to remain logged on to their Google account. All right, so that was the client-side flow. For those of you who are JavaScript developers, how many of you primarily code in client-side JavaScript? Okay, how many of you use Java? Okay, that's the majority of you. How many of you use Ruby and want to fight the Java guys? How many of you are forced to use PHP? All right. So if for you writing server-side code, the OAuth 2 server flow is for you. It's basically when you have your application on a secure server and you need long-lived authorization to access data. So in the example of the SaaSy Payroll application, like I talked about, maybe in the background as the company adds new payroll dates, you want to automatically add those calendar appointments to the user's calendar without them being logged into the payroll application. This makes it a lot easier for them, and for that case, you'd really want to use this server-side flow. This looks very similar, almost identical. You're basically passing in the client ID that you did before, the redirect URI, which is the URI of your website, the scopes, and then the response type in this case is code. Because in this case, you're requesting an authorization code as its intermediary value. And the authorization code basically allows you to do a server-to-server exchange to get the access token. This prevents the access token from ever being exposed directly to the user. And so all API calls that are made with the access token are known to be coming from your application. This makes it a little bit more secure. So the user hits allow access. And again, the user is redirected back to your application. But in this case, they're redirected back with a query parameter instead of a hash fragment. And the query parameter is this authorization code. The authorization code then needs to be exchanged for an access token. So again, you exchange it in a server-to-server flow for this access token. You pass in the authorization code, your client ID, your client secret, which you've kept securely on your server, and you get back this access token. Once again, this access token expires in about 3,920 seconds, but you also get this thing called a refresh token. A refresh token allows you to request offline refreshing of the access token. So we'll get to that here in a second, but our goal, like I said earlier, was this access token. So we have this access token now, and we can make API requests. API requests are made in the exact same way, although if you are using server-side code, you probably have even less excuses not to use the authorization header. So definitely encourage you to use the authorization header here. But you pass the access token clear in the URL or in this authorization header, and it's known as a bearer token because all you need to do is present that token and you'll have access to the APIs that were granted access to you by the resource owner. Now, when I say all you need to do is that, it's clear text, essentially a password to access the user's data. You don't need to do these cryptographic signatures. So you access the API, but then at some point in 3,920 seconds, this token expires and you need to renew it. You can renew this access token by calling the calling the OAuth endpoint and asking for a new token. You basically pass in your refresh token, pass in your client secret, and you get this new access token along with a new expiration date. Now you can wait until the access token is already expired, or if you know that it's about ready to expire and your user is actively using your application, you can improve the performance a little bit by requesting a new one shortly before it does expire. All right, so let's step through this server-to-server flow. Most of you develop on server environments. So let's step through this once more quickly to give it all to you on just 2 slides. Developer registers the application. The user visits the application SaaSy Payroll. SaaSy Payroll asks the user to authorize data access. The user hits the allow button, grants the access to the app. Google returns the user to SaaSy Payroll with this authorization code as a query parameter. SaaSy Payroll asks Google in this server-to-server call for an access token. Google returns this access token and a refresh token. Then the application SaaSy Payroll can add dates onto the user's Google Calendar by specifying the access token. Google returns the response. And then sometime later, if it needs to make other API calls, the application asks for a new access token by passing in that refresh token, and the application gets one. So fairly simple. I know it's many steps here, but this is much easier than OAuth 1. Would those of you who used OAuth 1 before agree? A little easier than signatures? All right. Google does support an additional OAuth 2.0 flow that I haven't talked about yet, and that's the device flow. This is if you do have devices which have limited access to a web browser. So think about something like an Apple TV, which doesn't have a web browser on it, and it needs access to, say, YouTube videos. The Apple TV can basically give you a URL that's kind of short. You go over to your web browser on your laptop and type in that URL, and then you get a code that you can type in on the Apple TV. A little bit more challenging than entering a password unless your password is really long, in which case this makes it a lot easier. And then there's the assertion flow. How many of you actually have heard of SAML or JOT? All right, not many of you. I'm not going to go into detail on this one, but basically this is to offer compatibility with OAuth 2.0 to other protocols and other ways of getting assertions of users' data access. Then there's a username and password flow. So think about something, we'll say like a Twitter client. Twitter client's on your mobile device. It's written by Twitter, the company. That application maybe doesn't want to do OAuth. Maybe it wants to just ask the user for their username and password. So it could ask the user for the username and password and then just send those back and forth to the server with every API call, but then it has to store the username and password on the device. This is bad. We'd much rather actually use OAuth as developers and as Google. We'd much rather the application used OAuth, but maybe they don't want to do that. Maybe they still want to have this prompt in their application for the username and password. Then what they can do is use things called the username and password flow of OAuth 2. This allows exchanging a username and password for a user for this long-lived access token and or refresh token, which allows them to basically forget about the password, not store the password on the device, not have to worry if the device is compromised in some way or the other. The most that someone that compromised the device would get is this OAuth token. And the OAuth token is revocable by the user. So much more secure than a username and password, but not as secure as the traditional OAuth flows. And then the last flow, which again we don't support yet, is this client credentials flow. So if you think of something like an application that needs access to its own data. So think about an application that needs access to Google storage or like an Amazon S3 or something like that. the application is acting on behalf of itself rather than acting on behalf of any individual user. And the client credentials flow is for that use case, where the application provides its own credentials and immediately gets an OAuth token to access an API. So the benefits of OAuth 2, there's benefits for both developers and for users. For users, you can leverage data across apps securely. So if you store your data in one place, you can securely leverage it in another application without revealing your username and password. Because you're not revealing your username and password, it basically reinforces this idea that you should never give out your password to an application. And it's this revocable access. So I can go to the Google Accounts page and revoke access to any apps which I've granted access to via OAuth. And that makes it a lot easier than, say, changing my password at every single application other than the one I need to revoke. OAuth makes it a lot easier. And there's this limited scope. So you're not granting access to your entire account, but instead just your Google Calendar or just your YouTube videos or things like that. And then for you as developers, you get to access this data without storing the user's passwords. Storing the passwords is bad, and it also leads to increased liability for you. So you don't want to do that. You can access data with OAuth without that. And then there's this industry standard. It's widely supported. Right now, like I said, a couple hundred different API providers are supporting OAuth 1, and as OAuth 2 is coming on board, more and more API providers are supporting it. So that was our discussion on getting access to a user's data. Now let's talk about getting access to the user's identity via OpenID Connect. So OpenID Connect is a protocol for federated identity. This means that one identity provider is asserting the identity of one of its users to your application. How does this work? So everyone say hi to Bob. Meet Bob. Say hi. All right, get some energy here. So Bob is traveling a lot. He's running a lot to different conferences, presenting everywhere, and he wants to keep track of all his itineraries. Bob uses a service called TripIt to do that. How many of you have heard of TripIt? Okay. A little bit more than past events in this area. But so TripIt is a travel planning service. It's a startup. It basically allows you to store your hotel and airline itineraries all in one spot. And Bob does that, and he's racing off to the airport, and he wants to figure out where his next flight is going to be. He knows he's flying, but he doesn't know where. So he goes to TripIt, and he says, TripIt, I want to use my Google account to log in. I don't want to have to create another username and password on your application. I want to just use my Google account to log in. So TripIt goes off and says, hey, Google, who is this guy? And Google says, of course, TripIt, this is Bob. And basically, TripIt trusts Google to assert the identity of a user. TripIt doesn't have a password for Bob. All TripIt knows is to go to Google anytime it needs to authenticate Bob. So in this case here, Bob is the end user, TripIt is a relying party, and Google is the identity provider. As a user, I'm going to hit Allow Access, and I'm going to be logged in. The application knows my name, it knows my email address, and it even has a little picture of myself. And we can see down here, I'm going to go to the fourth step here, and we'll see the other types of information it has about me. So email, name, given name, has a link to my Google profile, and even has this picture. See my picture a little bit bigger. And gender. We also, have some additional profile information that we get as more and more users fill out things like the Google Plus profile. We have more information to offer you as developers when those users sign into your application, and of course when the user grants access to that. So that's essentially how it works. It's the same type of flow as with Calendar. You're granting attribute exchange. Google supported some of that, but with OpenID Connect, we are providing a much richer profile to give you things like the photo and the gender and things like that you saw. And most importantly, it's this modular specification. So OpenID 1.0 and 2.0, if you were to be compliant, you had to implement a lot of different things, including something called discovery, which was rather difficult for many developers to implement. With OpenID Connect, basically it's a modular specification. you can implement just the parts of it that you want. There's a few required pieces, but then a lot of others. And we, in our initial launch, only have a little bit here. Well, it's not really launched yet. Like I said, it's a sneak preview. All right. So the first thing you're doing in order to do this, you saw this, is requesting a authorization. Same way as you do with OAuth 2. You're basically asking for an access token using any of the flows that we talked about. And the user approves that. And then you do this thing called verifying a token. The verifying token step is called an audience check, and it's basically to prevent replay attacks. So although it may seem in the protocol that you can skip this step, never skip this step. Please don't. We have this big red warning at the bottom. You never want to skip this step. This basically allows you to say this token was actually issued to your application as opposed to someone else's application. And if you want details on what the attack is later, we can chat. But you want to do this. And then the next step you do is request the user's data. This is using this user info API, which is a JSON feed, requesting the user's data, and you get back their name, their email address, their picture, that sort of thing. So benefits. Again, there's benefits for both users and for developers. For users, it reduces the number of passwords they need to remember and offers a faster sign up and sign in process. If you noticed here, when I signed into this new website, I just had 2 mouse clicks. Compare that to the 50 or 100 keystrokes that you would have to sign up to another website on a different site. Much easier. And then for developers, it reduces your need to worry about the complexities of maintaining an account system, of dealing with the security, dealing with users changing their passwords and all that. This makes it a lot easier. You don't have to deal with any of that stuff. You basically rely upon major identity providers to deal with that. And then reduced exposure to compromise. Because you don't have a database full of passwords, which at least if you have a database full of passwords, hopefully they are hashed in some way. But we've noticed recently in the news over the last year that a number of databases of passwords aren't even hashed. This is sad. But you don't have to deal with any of that. You don't have to think about hash functions. You don't have to think about what if my database is compromised in terms of which passwords and all are going to be revealed. You can just basically store the identifier for users and rely upon OpenID to authenticate your users. And then improve sign-up rates. Because it's a lot easier for users to sign up to your app, because it's just 2 mouse clicks instead of 50 or 100 keystrokes, you can improve your sign-up rates for your application. So the user experience is very important when it comes to OpenID, very important when it comes to this federated identity. And we've learned a lot over the years. And these learnings have basically been incorporated into our OAuth 2 approval flows and into our OpenID Connect approval flows. But there's some things for you as a developer to deal with as well. So when OpenID first came out, you basically had to log into a website with OpenID by specifying your OpenID, which was a URL. You basically would go to this text field and enter in a long URL and hit sign in. Very, very painful. Only geeks would actually use this interface. I could not imagine my mother typing in a long URL every time that she wanted to log into a website. So this wasn't that popular. OpenID didn't catch steam quickly. But instead, developers and the OpenID community learned a bit and offered what is called the OpenID NASCAR in the United States. Do you guys know what NASCAR is? Okay. NASCAR is basically, you have car racing, there's all the race cars are painted with ads all over the side of it. And that's what these websites kind of look like. They're basically painted with ads of all the major brands. And you choose the appropriate brand and you log in. And this was kind of the next generation of interface. And this was all basically done by individual application developers. We learned a little bit, made it a little bit better, and came out with this thing called the account chooser. The account chooser has been supported by the OpenID Foundation and is basically this specification for how the user experience should be for signing on to a website. So if you look at the right-hand side, you first start off with choosing your identity provider, similar to the NASCAR, I will agree, or you can enter in your email address. And as soon as you do that, let's say you enter in your email address and you have an existing password with the application, then the application will just prompt you for your password. This flow supports that. But if you use an OpenID, you can just click that button and you'll be signed in. And then the important thing with the account chooser is the chooser part of it. Although all of us likely are using our own laptop because it's on our laps for 20 hours a day and we get 4 hours of sleep, but the rest of the time it's on our laps, many users aren't like that. Many users actually still share computers, believe it or not. And so we've adopted the same type of functionality that's available in desktop operating systems like Chrome OS. And this functionality basically keeps track of the accounts that have logged on to this website recently. So if you go and visit the website and then you log out and your friend goes to visit the website and they log in and log out, and you go back to the website, you will be able to choose your account. Now this is important in the multi-user scenarios, but it's also important for geeks in a way too. It's important for geeks because you have many accounts. You might have a Yahoo account, you might have a Facebook account, you might have a Google account. You have different accounts and different providers. And when you go to log into a website, sometimes you may forget which account did I use to log into this site the last time. Well, this will tell you. It'll basically just list the different accounts which you've used to log in, and you can just click on one. And we'll give you a demo here in a second. But basically, the benefits that you have are simple upgrade from password-based accounts. If you do enter that email address and then enter a password, it provides a really easy upgrade flow. Switching between accounts is easier. It's based on this extensive UX research that Google, Yahoo, and many other providers have done over a period of time. And it's protocol agnostic. Although it's being supported by the OpenID Foundation, nothing about the account chooser interface is about what protocol you're using. It's just about what the UI should appear to users. And so that's really important. But if you want to go implement this, you don't want to make up all the JavaScript, CSS, and maybe even your server-side code yourself. So I'm going to talk with you about the Google Identity Toolkit. The Google Identity Toolkit basically makes it really easy for you to implement an account chooser style interface, which sits on top of OpenID 1, OpenID 2, and OpenID Connect for many of the different providers. So because we're in this period where the old protocols are still used and not everyone has adapted to the new protocols, and many of your websites actually want to implement with multiple OpenID providers, not just Google, you can use this sort of code, the Google Identity Toolkit, to make that process easier for you. It's a combination of JavaScript and CSS and a server-side API to make it easier to implement OpenID to multiple identity providers and also give you this account chooser interface. I'm going to show you with this OpenID sample store. The OpenID sample store is a fake store. Please don't go and put your credit card number in anywhere here. It is a totally fake store. You will never get your MacBook Pro if you ask for it. But anyway, if you go to the top and you hit sign in, you basically get this prompt. It says, what type of account would you like to use to log in? So I'm going to go and say, well, I use my Gmail account, of course. And I click Gmail. Oops, I didn't click it. And it's going to redirect me, and actually, apparently, I forgot to remove access to it, so I never saw that approval screen. But it's going to redirect me over to Google, and it redirects me back to the application, and I'm logged in. And then I have these options up here to switch account or sign out. Now, I sign out, and my wife later visits this store and decides to buy me a nice gift, a brand new computer or something like that. And she hits sign in. And she goes here and says, oh, that's not me, that's my husband. I want to add an account. She hits add an account. Now, let's say that she uses her Yahoo account. She doesn't know where the money's coming from, so she still is using Yahoo. She clicks on Yahoo, and she's redirected over, and she's asked to log in. And if I remember the password for this account, which I don't, work? Yes. So now it's going to log her in, and you can see her picture at the top here. Then she buys me my shiny new computer, and I never get it because it's a fake store. It's sad. And then someone signs out, or she signs out, and someone else goes to log in the future. Maybe I'm going to log in, and I can see here, this is the account I used. I can just click on that account and log in right away. Now this is going to require that I'm still logged into my Google account for this to work, but this interface will always appear, and if I'm not logged into my Google account anymore, it'll just prompt me to log into my Google account. So that is what the Identity Toolkit is all about, using that account chooser interface and providing a really great user experience for your users. But what is it like for you as a developer? As a developer, it's pretty simple. You start off in the APIs console just like all the other APIs. You basically say, I want to use the Identity Toolkit, put in some information about your application over here, and you choose which identity providers you support, and it gives you some JavaScript at the bottom. The JavaScript looks something like this. It's very simple. You just copy and paste it. And after you copy and paste this JavaScript onto your site, you do have to implement a little bit of a server-side interface to handle this. But we define what these different interfaces are. We offer client libraries in Java and PHP, but you can also code your own, and I actually, in fact, find that easier. It's a very simple REST-based API to code your own interaction with the Google Identity Toolkit. And you implement simple methods like this, like get accounts by email, or convert this existing account to a federated account. Very simple methods that you have to implement. And so, benefits, you get this pre-built account chooser UI. This is all the same infrastructure that Google uses, the same JavaScript, a lot of the same backends, APIs that it is calling. So basically, you can trust that this is the interface that's supporting Google's ability to federate identity. So if you, I don't know if you knew it, but you can actually log into your Google account using a Yahoo account. And this is all the same infrastructure that is used for that. And it hides most of the complexity. You get this REST-based API, you get this JavaScript and CSS and all that makes it easy to implement it. And it supports those legacy users. This is a key requirement from a lot of the big websites we work with. They still have users that have passwords and they want to support it. And like I said, libraries for various languages. So the last thing I want to talk to you about here is something that I added to this talk just for you guys. And it's because we increasingly are getting requests for how to deal with mobile. How do you deal with mobile when you're dealing with OpenID and when you're dealing with OAuth? So I work with a lot of apps marketplace developers. The Google Apps Marketplace is a business-to-business web application store, and we require all the apps to implement OpenID. So we can have this single sign-on experience between Google Apps and these third-party accounting or payroll or what have you apps. A lot of those companies come to me and say, I don't know how to do this, implement OpenID, because I need to authenticate users on my own native mobile applications. So how do I do that? So we're talking mobile use cases here. Authentication is the first one, and the process is pretty easy. Basically, you embed a web browser in your application and you use OpenID. There's an Android web view or iOS web view that allows you to do something like this. And if you use the Google Identity Toolkit, you actually automatically get a web-based or mobile web view of the account chooser, and where users can log in. Now, after a user logs in via OpenID, what your application does is generate a token. You basically generate a proprietary token, just like you would generate a session token for your application, and you generate that and hand that back to the application. You hand it back to the application in one of two different ways. We have an article on this about using a cookie manager. If you store that token in a client-side cookie, then your application can extract it from the cookie. Or the other way that oftentimes applications do is they include it in the title of the web page. And then in the title of the web page can be extracted by the parent application that embedded this web view. Then you just call the APIs. So you have this token that kind of represents your session token for your user. Ordinarily, this session token would be sent as a cookie back and forth with your requests. In this case, your mobile application uses that token and passes it via your API. So you have a REST-based API of some sort, and it passes it there. And then the other thing is authorization. Again, with authorization, you can embed a web browser, the web view or the UI web view. You get this access token from Google, So there's two ways you can do this. One way you could do it if you have your own web server that backs your mobile application. You can just redirect over to your server and just handle this normally like any other OAuth flow. The other way is using the native flow of OAuth, and it's passing in this redirect URI a special value, and then you can do this whole OAuth dance without actually having a web application. And then you just pass this access token in either the query parameter or in the authorization header to access APIs. And then the last thing I want to talk to you about, great, my background popped in there. The last thing I want to talk to you about is something new that we've done for Android and the Tasks API using the Google Account Manager. The Google Account Manager normally works with client login tokens, which is an old protocol that you don't want to use. We've updated the Google Account Manager to use OAuth 2 with the Tasks API. So basically you say, I want a token of type manage your tasks, and then the user is basically moved over to a Google interface called the Account Manager, which prompts them to allow or deny access. After the user hits allow access, your application gets an access token and then can call the APIs. So very simple. We have articles online to talk about this. So basically, you as developers have an obligation to help users stay safe, help users use good password practices, and you need to meet that obligation. You can meet that obligation by leveraging these standards like OAuth 2.0 and OpenID Connect. OAuth 2 allows you to securely access users' data. It's this industry standard. It allows you to prevent users from having to share their password in order to access their data on other services. Very simple protocol, much easier than OAuth 1 because we eliminate these cryptographic signatures. And then secondly, OpenID Connect for federated login allows users to easily log into your applications without having to remember another username and password. Remember, 2 clicks instead of 50 or 100 keystrokes. And it's all built on OAuth 2 and has this account chooser interface to make a great user experience. That's all I have. Here are some resources and my Twitter handle and Google profile for Google+. Thank you very much. Now, do people have questions? I'm not sure how much time we have left for questions, but I have some pins here to give out for people that ask questions. We have some App Engine pins, some Geo pins. Unfortunately, we don't have any with the OAuth logo on it, or OpenID Connect logo, but who wants to ask questions? Stand up and just yell out your question. Unfortunately, we don't have mics, so.
So I had a question around OAuth 2. With OAuth 1 and all this cryptographic stuff, you're safe from man-in-the-middle attacks. How do you handle that with OAuth 2?
That's what SSL is there for. So the question was, you're safe from man-in-the-middle attacks and things like that with OAuth 1. How do you handle that with OAuth 2? Basically, you're encrypting the connections over SSL. You're verifying the SSL certificates when you're calling these APIs. OAuth 2 heavily relies upon SSL as a way to provide security.
So the end user needs to make sure that there is no third-party proxy in between the service that would break the SSL chain?
Yeah, the end user, needs to do the standard sort of SSL protections as is done.
Typically, SSL doesn't help you to deal with the man-in-the-middle attacks, right?
Yes, it does. SSL, you're verifying the certificates of the website or whatever that you're connecting with.
Do you have a proxy in the middle that can...
Then the user's configuring that proxy. Well, we can chat more afterwards. I do have to vacate the stage here, I think. I realize these sessions are back-to-back. They're hour-long sessions, but the next one's supposed to actually start now. So I'm available. I'm in office hours, I believe, coming up here in the next hour. Or you can come up here and we can talk as we're walking out.